Introduction to ocean tides. Ocean tides are a fundamental aspect of coastal and marine environments, influencing everything from navigation to marine life. The primary force behind these tides is the gravitational pull of the Moon, which interacts with the Earth's oceans to create the regular rise and fall of sea levels known as tides. Understanding this process reveals the intricate relationship between celestial bodies and Earth's natural systems. Gravitational pull of the Moon. The Moon's gravitational force exerts a significant influence on the Earth's oceans. This pull causes the water on the side of the Earth closest to the Moon to bulge outward, creating what is known as a high tide. Simultaneously, a second bulge occurs on the opposite side of the Earth due to the centrifugal force created by the Earth-Moon system's rotation. This dual bulge results in 2 high tides and 2 low tides in most coastal areas each lunar day. Centrifugal force and tidal bulges. The Earth's rotation and the gravitational pull of the Moon create centrifugal force, which contributes to the formation of a second tidal bulge. As the Earth and Moon orbit their common center of mass, the centrifugal force causes water to move away from the Earth on the side opposite the Moon. This force balances the Moon's gravitational pull and contributes to the tidal cycle, resulting in the characteristic rise and fall of ocean levels. Influence of the Sun. While the Moon is the primary driver of tides, the Sun also plays a significant role. The gravitational pull of the Sun affects the Earth's oceans, but to a lesser extent than the Moon. When the Sun, Earth, and Moon are aligned during full moons and new moons, the Sun's gravitational pull combines with the Moon's pull to create particularly high and low tides, known as spring tides. Conversely, when the Sun and Moon are at right angles relative to the Earth, their gravitational effects partially cancel each other out, leading to neap tides, characterized by lower high tides and higher low tides. Tidal cycles and patterns. Tides follow a predictable cycle, influenced by the Moon's orbit around the Earth. Typically, most coastal areas experience 2 high tides and 2 low tides within a 24-hour and 50-minute period, known as the semi-diurnal tide. In some regions, known as diurnal tide areas, only 1 high tide and 1 low tide occur each day. These patterns are influenced by the Moon's position and phase, along with the Earth's axial tilt and orbit. Regional variations. The impact of the Moon on tides varies by location due to factors such as coastline shape, ocean depth, and local geographic features. In some areas, tidal ranges can be quite dramatic, with significant differences between high and low tides. In other regions, the tidal range may be minimal. Coastal features like bays and estuaries can amplify or diminish tidal effects, creating unique tidal patterns in different parts of the world. Impact on marine life and ecosystems. Tides play a crucial role in marine ecosystems, influencing the distribution and behavior of various marine species. Many organisms, including fish, crustaceans, and marine plants, are adapted to the rhythmic changes in water levels. Tidal zones, such as intertidal areas, are particularly rich in biodiversity and are critical for the health and productivity of coastal environments. Human activities and tidal influence. Human activities are also affected by tides. Coastal communities rely on tidal patterns for fishing, navigation, and recreational activities. Additionally, tides are harnessed in tidal energy projects, which aim to capture the kinetic energy from tidal movements to generate renewable energy. Understanding tidal patterns is essential for planning and managing these activities effectively. Conclusion. The Moon's gravitational pull is the primary force driving ocean tides, creating regular cycles of high and low tides. This interaction between celestial mechanics and Earth's oceans has significant implications for marine ecosystems, human activities, and the overall health of coastal environments. The predictable nature of tides, influenced by both the Moon and the Sun, highlights the interconnectedness of astronomical and terrestrial systems.